Sweet. So thank you so much for joining us for the 2024 Route Optimization Tool webinar. This webinar will provide an insight to the forecasted conditions for event day and show you how to use the forecast to your advantage when using the Route Optimization tool. So I'm JC, the event coordinator from the Rottnest Channel Swim Association, and we are a not-for-profit organisation that run the 2024 South 32 Rottnest Channel Swim. And we are joined by our tool developers, so both Aurora Offshore Engineering and UWA, and I'll let them introduce themselves now.
Yeah, thanks, JC. So my name's Scott Draper. I work at the University of Western Australia, co-developed the app here with Terry and with Ivica. Ivica, you happy to introduce yourself and then Terry?
Yes, so my name is Ivica Janekovic. I work at UWA together with Scott. I'm a physical oceanographer, and I'm running the atmosphere and the ocean models that are predicting the ocean currents and winds that we use in our app for the optimization of the route.
And hello, everyone. Thanks very much for joining this webinar. My name's Terry Griffiths. I'm a subsea engineer and work for Aurora Offshore Engineering. And our primary interest as a professional is in offshore renewable energy. But both Scott and myself are quite keen open water swimmers, and signed up again on Saturday to do yet another solo crossing to Rottnest. And so, having actually for over a few years developed this route optimization tool, a couple of years ago, we collaborated with the RCSA to actually open it up and turn it into an app that everyone can use.
Yeah.
Perfect. Cool. Alrighty. So just quickly before we commence the webinar, just some housekeeping details. So if you have any questions, you can use the Q&A functionality. So if you're on like a laptop or a big screen, across the top of the toolbar, you'll see a Q&A field. Or if you're on a smaller screen, such as a smartphone, you might not have the full options. So if you just select the three dots, which says more, you'll be able to find the Q&A section through there. Feel free to post a question throughout. However, we will wait until the end to go through over any questions. So if you want to pop it through as you notice something, or wait till the end, we'll open up to a Q&A session at the end. Perfect. Alrighty, I'll hand over to Scott to start the presentation.
Yeah, thanks, JC. So hopefully you can see my screen and a PowerPoint slide. Yeah. So what we're going to do today is similar to what we've done in previous years, but we'll go through, first of all, with Ivica talking to you a little bit about the modelling that he does, the oceanographic modelling that allows him to predict and forecast, I should say, the ocean currents. And those ocean currents you can access and look at directly. We'll show you how to do that. They're also the same currents that we feed into the route optimization app, which we'll show you next. So that's the second thing that we'll go through today. We'll talk to you a little bit about the app, what it does, how to use it. And then to finish, Terry will talk a little bit about some of the insights that he's gathered from using the app, and we think are particularly useful for you to know as well. And then, yeah, Q&A afterwards. So if we start then with Ivica, looking at the Rottnest Channel currents. So are you happy to talk through this?
Yeah, sure. You all know that it's kind of pretty hard to predict the ocean currents. And just to illustrate that, we are showing you that figure, which is showing you the chlorophyll in front of the Western Australia. So lots of eddies, lots of small scale features. And if you want to be 100% sure how the currents are going to look like at a certain point, it's really hard to predict with a high kind of like probability. So what we do is we try to tackle this problem by using the numerical models, which are solving the so-called Navier-Stokes equations, which are describing the motions of the fluid. And in that sense, we are computing the ocean currents within the models. So I don't know about the other website that you might use for the weather prediction or ocean prediction. Are they just kind of like picking up information from the web, or I don't know, providing some other kind of information, but we are actually computing that information. So this is our advantage. We have under our control our models, our setup, our local knowledge that we can use to tune all these models to give us, let's say, the best possible focus for the ocean. Yes, if you can slide in. So, you know, you can look at that basically you have to run the model for the Perth region, but before that you have to run the model for the whole Western Australia, because the global models and that big model is not good enough to predict you a high resolution ocean currents around the rot nest, because rot nest is the obstacle in the flow, and that shallow area with really complex bathymetry is really poorly resolved in the big models, in the complex, in the big global models. So this is why, for example, it's not really wise to use the global models like HiCom or BlueLink, for example, in Australia. They are order of tens of kilometers, and they cannot see actually the rot nest island within the domain. That's why we have kind of multiple nests of the models, starting with that WA, the whole Western Australia model, which is running at 2 kilometers. And then within that model, we even go further on high resolution around the Perth to 500 meters. And that 500 meters model is capable of resolving the physics at the appropriate level, especially the ocean currents around the rot nest. So in this sense, I think we are providing one of the best source of the ocean currents, which does exist actually in anywhere. So just to show you how does it look like, Scott is going to flip through the few images. So what we use is actually we have to run the atmospheric model as well, which is then forcing our ocean model. In that sense, we are using winds, temperature, rainfall, you know, heat flux, and all other important variables. So we are producing the results from the scratch using the atmospheric model coupled to the ocean model at the same time. So just to give you the example, this is rot nest swim prediction for 2021, which is going to be pretty similar to this year, as you will see later. So on the left figure, you have that 2 kilometer whole Western Australia ocean model, and within that model, in that red box, we actually put another model which is running at 500 meters, and on the right side is another test model which is running even on 100 meters. So, you know, we are having a suite of models that we test and see what is the optimal resolution for the models to resolve the dynamics. And you can see that the dynamics is pretty complex. You know, you can have this kind of increased ocean currents closer to rot nest and weaker currents at the Cottesloe, which you might actually experience before. So next slide. Just to give you the idea, how does the 2 kilometer model see the rot nest? This is on the left side. So it's really coarse resolution to compare to this one at a 500 meters. That's why we have to nest and compute even more numerical points to get better result. Next.
Yeah,
so you can actually have a look at the website at UWA. What is the current forecast for this event? So if you go on the website called myocean.mywire.org/WA, and then on the top tab you have these events. If you click on it, tomorrow you will have better basically results, because the model are going to run over the night and produce the new numbers. So what you can see is, if you can click, for example, at the 6 o'clock in the morning, let's say, so this is the time, then you have the figure what we could expect at the swimming route early in the morning for the surface currents. So you can see the color, it's kind of yellowish, and that yellow on the color bar means that we are at a half a meter per second, which is actually 1 knot. So you could expect at 6 o'clock in the morning currents pushing you north up to 1 knot. And as you go further in time, you will see the currents are going to increase a little bit. So you have hourly snapshots. Those arrows in the middle of the graph is actually showing you like time chart. So if you start at the beginning at 1.5 kilometer mark at, let's say, 6 o'clock, so you are expecting really low currents. As you can see from the figure, it's bluish, kind of really variable. So, and as you travel through the time and swim, you're actually going on the diagonal of that plot. And you can see what you can expect at different marker, which is on the y-axis, and on the x-axis you have time. So you can actually draw a line of your swim and see what currents are more likely going to be along your path. And on the bottom one, you have prediction for the winds. So at the beginning, you can see that the winds are really weak. And then later they're going to pick up to be like typical sea breeze, but coming up a little bit early in the morning and getting the basically around the 11 o'clock, 17 knots. So all that situation is kind of really consequence of the bigger atmospherical system. And as you know, on the north, we have developing tropical cyclone. And that tropical cyclone is actually, so you can see that on the, for example, if you zoom out a little bit, on the windy, you have that tropical cyclone, which is most likely going to develop on the northwest shelf. And this tropical cyclone is actually sucking all the air from our area and increasing those winds, basically increasing the sea breeze. And if you click on the other models, so this is one global model called ECNWF. If you click on another model, which is GFS, it's pretty consistent, showing again tropical cyclone developing. Not at the exact position. That's why we'll have to wait a little bit more to get really reliable forecast. But they are all showing basically increased that sea breeze kind of typical wind along the Perth waters. So in that sense, if the tropical cyclone is going to develop, and most likely it will, we'll have stronger winds at the Rotten Swim, which consequently are going to produce stronger surface currents, as you will see. So more or less, that's all from me, I think. If you have any questions, feel free, and I'll try to answer later.
Yeah, so bits of these current forecasts that you're outputting to this website, they include boundary conditions that incorporate the forecasted cyclone?
Yes, exactly. So we are running the big model, which is actually feeling that tropical cyclone and propagating that information to that finest model. So that finest model is actually seeing what is going to happen through the boundary conditions, which are kind of a way of doing the modeling.
Yep. Okay, and then you can click up here to see how the currents evolve during the day as a contour plot. Yeah.
Yeah, and this is all in local time. So if you start swimming at 8 o'clock, you can see along your path most likely how the currents are going to develop. And as I said, it's going to be currently it looks like it's going to be pretty similar to 2021, with having the northward currents, meaning that those currents are going to push you towards the north. So later on, you will see the optimal route is going to provide you southern route, basically, to capitalize on that weak currents at the beginning, and then to be basically carried with the currents to the north.
Yeah.
Yeah.
Okay. So yes,
and
hopefully
model is refreshing the results every day around 8:30. So every day at 8:30, you will have the new set of the the figures, and you know, all our information is going to update. So the last basically useful information for you is going to be probably day before.
It's on Friday at 8:30 a.m. Yep. Okay. Excellent. Right, we'll keep moving. So the next part of the talk is on this route optimization app. So we're going to sort of talk through, this is the app. We'll show you how to use this on the website, and I'll show you how you can access this website through the Rottnest Channel Swim Association website. We're just going to talk about a couple of things really quickly in terms of the background. So we'll talk a little bit about why the optimum route is not straightforward. Then we'll show you how you can find and use the web application. And then Terry will talk through some interesting things you can explore with the web application. So why is the optimum route to Rottnest not straightforward? So the easiest way to demonstrate this is essentially an output similar to what we just showed you from Ivitz's webpage, but this was for 2021. And you can see that this looks relatively similar actually. This is for 12 o'clock, so midday. And you can see that the currents are to the north with these arrows indicating the current direction. And the colors here are indicating the magnitude of the current. So orange and yellow here is a larger current, and green and blue is a smaller current. So you can see that the currents are to the north, and you can see that they're not uniform across the entire channel. And it's that non-uniformity that means that we can start thinking about an optimum route. So for instance, if we're trying to go from Cottesloe, which is point A, to Rottnest, so point B here. If we were to just swim along the run line and try and hold to the markers the whole way across, at some point we'd end up maybe around here, the 14 to 15k mark at midday, and the currents here would be pointing in this northerly direction. So if we want to continue to go on the run line, what that means is we sort of have to swim in this direction, the direction of this blue arrow, so that when we combine our swimming and the current direction, we head forwards in the direction of the run line. That's not good because most of our swimming is actually fighting the current, and only a small fraction of our swimming is actually sending us in the direction we want to go, which is towards Rottnest. So it's not good to be on the run line at this location of the swim with those fast currents going to the north. If we were instead down here at this part of the swim, we'd still be experiencing these currents. But now we're not trying to go in the direction of the run line, we're just trying to get towards our destination. And so we still have to swim at a slight angle, but a much larger fraction of our swimming is in the direction to the west, which is where we want to go towards Rottnest Island. So you can see how where you are as you get close to Rottnest is important for understanding how much of your swimming speed is going to be helping propel you towards your destination. So what all that means is that if we were to think about an optimum route for this particular sort of current distribution, the optimum route looks a bit like this red line. And the idea is that you swim south during the first half of the swim, where it's quite easy to swim south because there's very little current to resist you. And then when you get towards this side of the swim, you can let that current bring you back up towards the run line. And most of your swimming is directing as much as possible to the west. So you end up with these sort of curved routes that give you a faster crossing time than if you were to swim directly along the run line and try and hold the run line. Now, the particular route that you take depends on your swimming speed. So for example, this red line here is for somebody that's doing on average 15 minutes per kilometre. This would be their optimum route, and they would get to Rottnest on this particular day in 5 hours and 9 minutes. If you were someone that swims a bit slower than a 15 minutes per K, then your optimum route would actually see you deviate further from the run line. So this just gives you an idea of someone swimming at 23 minutes per kilometre. And your time then would be 8 hours and 41 minutes. because you are swimming slower, you have to position yourself further south to really, I guess, minimize the effect of the currents as much as possible. In the limit, if you were like a ridiculously fast swimmer, then of course the currents would have no influence on you and you would go along the run line. So we sort of see this trend that as your swimming ability increases, your routes tend to be closer to the run line. And as your swimming ability is less good, you tend to get routes which are further from the run line. Okay, so the obvious question would be, is it worthwhile to take these optimum routes? And to do that, you can compare the estimated time to do an optimum route to the estimated time to swim along the run line. And when we do that for that 15-minute per K swimmer, when you swim along the run line, you would be 3 minutes slower than if you took the optimum route. And if you were the slower swimmer, you would be actually 55 minutes slower if you were to swim along the run line. So you can see for a fast swimmer, the benefits of taking an optimum route are smaller in an absolute sense. If you're a slower swimmer, the benefits of taking the optimum route are significant. But for both of these types of swimmers, we think it's important because if you're a fast swimmer, 3 minutes could mean the difference between finishing in the top 50, or could even be the difference between winning or losing. If you're a slower swimmer, this 55 minutes, which is taking you out to 9.5 hours, can be the difference between finishing or not, right? So we think, these optimum routes can be very helpful, whether you're trying to win the race or just trying to finish the race. In fact, most useful for people just trying to finish the race. Okay, so that's some background. The optimum routes that we calculate, we do that using an algorithm where we search through a wide database of routes, and we find the best route using the currents that Avitsa simulates and forecasts for the race day. What I'll show you now is I'll just show you, just close that. So how do you find the route optimization software? You can just come into the Rottnest Channel Swim Association website. And if you click on pre-event, you can come down to route optimization tool. And if you click on that, you'll get a link through to the tool. Just one sec. And that takes you through to this website. There's some text up here which we'd encourage you to read. I'm not going to read through it now, but you can definitely read that at your own time. And we have this disclaimer text in red, which is essentially what Avitsa just told you about the forecasting tool. So the forecasts are now going directly into this route optimization app. And every morning, we've said here 9 a.m., but 8:30 to 9 a.m., the forecast will be updated. So the best time to really come on here and get your final route would be after 9 a.m. on Friday this week. And that will be when we have the last and best forecast uploaded into the app. Okay, so the way you would use it, we just have some simple inputs here. So you might start off with your team name. So I'm just going to call this team test, and you might want to put in your swim number. And then you get asked what time you're starting. So everyone should now have an idea of their start time. So depending on what wave you're in, maybe you're starting at 6 o'clock or 10 past 6. You then have an ability to choose different years, and we've got a few years loaded. We've also got no currents loaded, so you're welcome to try those out. For this year, obviously, we'd click on 2024. Okay, then we have a couple more inputs which are really quite important, and Terry will talk about these a bit more. But these next two inputs are you specifying your swimming pace. So what we need you to do here is to specify both an initial pace, which you think will be the pace you'll be going at the start of your swim. And then we need you to give us a pace that you think you'll be holding after 10 kilometers. Now, the important thing about these two paces is that these need to be paces that you would do essentially in a swimming pool, right? So not accounting for any effects of environmental conditions like waves or currents. If you were going to swim for a long swim, what would be your initial pace, and what would your pace be after 10 kilometres? One way to estimate this is to use your qualifying swim, and I'll let Terry talk about that a bit more later on. So I'm just going to put in here some example values, so maybe 19 minutes per K to start, and maybe slowed to 20 minutes per K at halfway, or after 10 kilometres. Okay, then next thing you need to put in here is your feeding interval. So maybe you're going to feed every 30 minutes, and then your feeding duration. So maybe you're going to take 2 minutes to feed, just as an example. If you're a team or a duo, of course, you can just put 0 for both of these inputs, because you will just always have a swimmer swimming. Hopefully, you won't be stopping to feed in the water. And so once these inputs are included, you can then click on Calculate Route. If anything's not clear, we also have some information tags here which you can click, and it gives you a description of what we're asking for at each of those inputs. So I'm going to click on Calculate Route now and cross my fingers that hopefully we get a nice solution. Okay, so we've now got a route that's been calculated. Now what's popped up here is a warning, and this is quite useful that this warning's popped up. So some of you, when you run the app, will get this warning. What this is telling you is that your optimized route has been restricted to be no more than 1.5 kilometers south of the run line. So I showed you earlier, the slower your swimming speed, the further your optimum route will deviate from the run line. But what we do in the app here, for a number of reasons, is we limit the optimum, or the offset, to a maximum of 1.5 kilometers. So if your swimming inputs are such that you would have an optimum route that goes beyond 1.5 kilometers, we're going to restrict it back to 1.5, and you'll get this warning just to let you know. So you just click OK. And what you can see now is a sketch of your optimum route. You can see here that you're going to get a maximum offset at around this 13 kilometer mark. And you can see these arrows are indicating the direction, and the length of the arrow indicates the magnitude of the currents that you'll be experiencing at each of these locations. So what's important in terms of outputs? There's a few different outputs that you can get. Probably the first one that you will see is this table. What this table does is it gives you, at each kilometer location listed in the first column, it tells you what time, in terms of clock time, you expect to be at that location. So 6:10 is when we leave, and then 6:40 is when we get past the tall ship, the Lewin. And then as we go further on throughout the day, we can see how the time's changing. And in this particular case, we will arrive just before 2 p.m. This column is then telling you your distance offset from the run line. And you can see here, the distance is increasing. It's negative because it's south of the run line. Eventually we get to this cap of 1.5, and then we start to come back towards the run line. And then this red one is just giving you the time since start. So essentially it's the clock time minus the 6:10 a.m. start time. So you can see here it's going to take 7 hours and 43 minutes to complete that optimum route. There's a couple of useful metrics down the bottom. It tells you what the time would take, how long it would take you if you kept on the run line. So in this case here, it would take you 8 hours and 34 minutes, almost 35 minutes to do the swim. If you didn't take an optimum route, you just followed the markers. So that's a pretty big difference in this particular example. We also tell you how far it'll feel like you've swum if you kept on the run line, and it will feel like you've done a lot more than 19.7 Ks. And that's because, like I showed before, to hold the run line, you're actually not always swimming in the direction of the run line. So you're actually wasting a bit of effort, and it makes you feel like you're swimming much further. If you take the optimum route, you'll also feel like you're swimming a bit further, because there's still going to be currents present, but you won't feel like you've swum anywhere near as far. So in this case, almost 2 or so, 2.3 Ks, almost less. Okay, so that's the way the tool works. You can get a couple of different outputs from it. If you click on here, you'll get a PDF that will automatically download. If you load that, it just looks like this. What the PDF is giving you is the latitude and longitude of your optimum route. So at each of these locations across the channel, it's giving you the lat and long of the points that combine to form your optimum route. So if you wanted, you could take this and you could input this into any device manually you liked to create a series of waypoints, if you like, to create a route. Alternatively, and what we'd probably recommend is you download this GPX file. This GPX file also just automatically loads. If you open it, it'll look interesting. So it'll look like this. It's got a whole bunch of coded coordinates, but you can feed this GPX file into a number of devices that will read GPX files, like Garmin will read it, a Garmin device. You can also feed this directly into the Roto Swim app, and there's some guidelines on how you do that on the web page for the Rottnest Channel Swim Association. So a bit further down here on this web page, it'll talk to you about how you can upload your GPX file into the Roto Swim app. And then you're essentially good to go. Once you've uploaded that into your device, you can follow that route on the day and off you go. So there's just a general idea of how you use it. We'd encourage you to play around a bit. You can think about pacing. You can think about feeding intervals and see how that influences your swim. So if you remember here, I'll just show you quickly 7 hours and 45 minutes to do the swim. What happens if I was a bit faster with my feeding? So maybe 60 seconds, and maybe I took 45 minutes between breaks. I'm not a nutritionist, so I've got no idea what I'm doing here. I'm just showing you what happens if you change these numbers. Then we still have the warning, but you can see we've actually managed to take a bit of time off our swim. So every second matters when you're feeding, and you can see here that the swim time is now reduced quite a bit. Okay, so that's just an introduction to the app and how you use it. So what I'll do now is I'll jump back into the presentation. And we'll run. Terry, you happy to run through these final few slides?
Yeah, absolutely. Thanks very much, Scott and Vitsa. So the focus of what I'm actually going to talk about here is just some of the insights that you can actually get if you have the opportunity to play around with the route optimization app. So the first thing to notice is that if you feed in different paces from anywhere from 13 to 27 minutes per kilometre, it adjusts the offset that is the optimal. And the reality is that the faster you go, the less that offset needs to deviate from the run line. And as we've talked about already this afternoon, this data is based on the currents from the 2021 Rottnest Channel Swim, which actually looks like it's going to be fairly close to the conditions that we're expecting for this coming Saturday. So the faster you go, the quicker you get there. Now that sounds like a really trite thing to say, but it is actually relatively important here in terms of understanding the link between the route that you take and your speed. So if you see other swimmers taking a different route and you've actually picked your particular pace and planned around maintaining a particular pace, that doesn't mean that they're going the wrong way or that you should change what you're planning to do in order to follow them. It's something that the idea behind this and actually having it as an app is that each swimmer can actually tailor their particular optimized route to suit their particular swim plan. So next slide, please. One of the really important things to understand out of the way in which the RCSA set up this swim is the importance of safety. And one of the most important safety aspects of the swim are the support vessels, the rescue vessels that actually are able to respond incredibly quickly to any swim emergency across the course. And the most important part of that is that those rescue vessels can go quickly. And that means that there needs to be no swimmers and no support boats in that northern rescue corridor. So the currents are for this year expected to come from the south to the north. However, it isn't always that way. And so in 2017, we actually had the currents coming from the north to the south, and the optimum route got as close as possible to that northern rescue corridor, but didn't go inside it. And the route optimization tool is coded in such a way as it won't give you a route that goes inside that rescue corridor. However, given that conditions are forecast to be very similar to 2021, one of the reasons that this route optimization tool can be very helpful is that in 2021 Rottnest Channel swim, there were a very large number of vessels that actually drifted north into the rescue corridor, and their swimmers were ordered to exit the water because they were unable to actually get back into the legitimate swim course. So for skippers and for swimmers, please be very aware that again this year there's been the innovation that there's the yellow catamaran will be located at the 18-kilometre mark, and you have to stay outside of the rescue corridor for safety reasons. So please be aware, especially as you get close to Rottnest, that the currents are likely to get much higher velocity, and you have the potential to drift north into that rescue corridor very quickly. Next slide, please. So there's another really important strategy, and for this coming Saturday, it's going to be far more important than it was last year. So for anyone who's doing another crossing this year compared to last year, comparisons with last year are going to be of relatively limited benefit to you. It's incredibly important that you understand the effect of pacing. And I saw that there's actually a question that's been asked by someone about, what if I've got 20 minutes at the start and then I slow down to 24 minutes by 10-kilometre mark? So the way the model works is that will say, right, well, by the time you get to 20 kilometres, you're actually not swimming at 20 or 24 minutes per kilometre, you're now out at 28 minutes a kilometre, and you may not be swimming fast enough to actually finish the race in time. And so the way the route optimization tool works, and actually the way swimmers behave in waves and in currents, as you're swimming further and further, it is perfectly natural for your arms to get tired and for you to slow down. However, the tool actually enables you to have a look at what that will do to your finishing time. And what we've shown over a multiple range of different simulations is that the fastest time any given swimmer can swim from Cottesloe to Rottnest is to try as best they can to hold a constant pace. So the clear kind of benefit is to actually maintain a constant pace so that towards the end, towards Rottnest, towards Phillip Rock, where those currents are the strongest, you're still going at the same pace as you left the beach. Now, you can't go so slow that you're not actually going to get to Phillip Rock, but it means that you've actually got plenty of fuel left in the tank. As Scott suggested, you should potentially have consulted a sports nutritionist or gone along to the RCSA has a nutrition seminar. I don't know if the video or the recording of that might be available, but actually your nutrition and your energy levels as you are having swum for now quite a few hours and you're in the waves and you're in the currents, that's the point where it's incredibly important that you actually maintain your stroke rate and you maintain your stroke skill to actually keep moving through the water. It's at that time that you're being pushed north most strongly by the currents. And what you can see here is that the optimal time is by achieving a constant pace. All right, next slide, please. So how do you go about figuring out how far are you going to swim? How fast are you going to swim? Well, it's actually not intuitive. And so it's fairly common for us as open water swimmers to be able to swim in either a 25-meter pool or a 50-meter pool. If we're just sprinting one 25-meter length or one 50-meter length, we can do that much faster than we could swim 10 kilometers. And so one of the things that's necessary to actually be approved to do a solo crossing is that you actually complete a 10-kilometer qualification swim. And those 10-kilometer qualification swims can actually be incredibly helpful for you figuring out what your pace might be on race day. So, for example, one of the things that most of the 10K qualifying swims give you is a breakdown on how long it took you to swim each lap. And so one of the things that can be incredibly helpful is to actually understand how fast did I swim the first lap compared to how fast did I swim the last lap. There are a couple of things that are worth bearing in mind. Is actually it's helpful to know that the first lap is sometimes a tiny bit shorter than the others, and often the first lap doesn't include a feed stop, whereas often the last lap or the second last lap, so the laps might have feeding in those affecting those times. But the 10-kilometer pacing, how well did you do in the first lap compared to the second, third, and all the way through to the last lap, gives you some measure of what your particular rate of fatigue is. And as best we've found, that's the best measure that we can come up with for regular swimmers. If you've already done a roto crossing, if we can go to the next slide, please. If you haven't actually, if you have completed a previous Rottnest channel swim, one of the things that the route optimization tool enables you to do is to actually sample the weather conditions, the predictions of the currents from a range of different years. So if your previous swim was in one of those years, then potentially play around with the timings until you actually get match the finishing time that you actually achieved over 19.7 Ks. You can then swap to 2024 and rerun with those conditions, and that will then give you the pace, the anticipated optimized route for what you would do if you had the same level of fitness and the same preparation as for that prior year's solo crossing. We do tend to talk about solos, but these, as Scott said, the tool can be equally well used for teams and duos. Again, any of the prior swims that the team have done can help to understand what the likely pacing of the team is over the 19.7 Ks. And one of the benefits of being in a team or a duo is that you're swimming less distance overall, and therefore you're more likely to wind up being able to maintain your swim pace and not slow down as much. But as Scott said, we encourage you to play with the tool. We encourage you to try out different inputs and actually see how it affects your predicted swimming time and your predicted optimized route. And I think that's probably the last slide. But before I finish, there is one more. And that is just be aware as you get out towards Rottnest and the currents are howling to the north, and I'll confess this is actually GPS data from my crossing in 2021, and you can see just how far I drifted north in roughly a 3-minute feed stop. And then you can see that we actually had to fight our way back onto the optimized route. And I can tell you that was really hard. So just be aware that feeding times, Scott made the point that feeding times matter. They matter out near Rottnest when the currents are strong, way more than they do when you're just off the beach at Cottesloe. The last thing to say out of all of this is, given the forecast, actually holding to your planned route is not a straightforward, easy thing to do. And we've now been using this route optimization tool for 5 years, something like that, and actually playing with it for both Port to Pub and for Rottnest crossings. And what we've found works best is for the kayaker to focus on kayaking and focus their attention on the swimmer, and for the support crew on the support boat to have the GPS and to be monitoring the track of the swimmer and the kayaker compared to the optimum route, and actually calling out instructions to the kayaker. The swimmer can't hear anything. It's the communication between the support boat and the kayaker that is critical, and having if you've got a handheld GPS or a chart plotter on the support boat, having the optimized route loaded into that using the GPX file that Scott talked about, that seems to be the most effective way of actually maintaining a reasonably good match between the course that you actually swim and the target optimum course. And for this coming Saturday, it's probably, if you're going to be off the course, it's probably better to be slightly off on the south side rather than the north side, just given that the conditions are forecast to be fairly bad this year.
Okay, cool. Thanks, Terry. Well, not cool about conditions, but cool about end of the talk.
So we will say, Scott and I are lining up to actually swim with everyone on Saturday morning, I'm looking forward to finishing.
Yeah. So we've got some questions. Did you want to go through those, JC? Or?
Yeah, I can read them out. So what I'll do, if you are listening or watching this one, I'll read through the questions we've got now. If you did have any other questions you were waiting until the end, feel free to pop them in, ideally in the Q&A section, but I will read out both of them now. So going back from one of the first ones, Benjamin R asked, so this is a statement. So I noticed the tool does not give you the distance of the optimized route versus straight line 19.7 kilometer. Are you able to talk to the difference in actual distance swim for these examples?
Yeah, I mean, we could give you the arc distance. We just haven't.
It's not particularly relevant. Because it's not what you actually experience as a swimmer.
Yeah, so if you remember, I said that we plot what it feels like you've swum, which in our minds we think is much more relevant. But the distance actually is not a lot longer on the optimum route. I mean, we're offsetting 1.5 Ks off the run line, but that's a 1.5 K offset over a 20 K distance. So it's not a lot longer, that arc length, if we were to work it out. But what is a lot longer is the perceived, or what it would feel like the distance is if you went on the run line compared to the optimum route.
Perfect. Alrighty, we will move on to the next question. So the next one is from Ray. So does the initial pace cover first 10 kilometers and pace at 10 kilometer cover 10 to 20 kilometer? The reason I ask is our swimmer off the beach is much faster than the rest of his team. His pace is 15 minutes per kilometer, and the team as a whole is a bit higher, sort of 18 kilometers per hour. Per minute.
per kilometer, yeah. So that's a good question. So for a team, what you sort of need to do is work out your average pace across all of your swimmers, and then what we'd normally expect for a team is probably less fatigue, especially for a team that's trained reasonably well. So what we wouldn't be surprised seeing you do is averaging your swimmers' speeds, and then probably just keeping the initial pace very similar to the pace at 10 kilometers. And if you have a good idea of how each of your swimmers in the team will sort of deteriorate, you could, for example, average their initial paces to get the initial pace, and then average their paces at after swimming at 2.5 Ks to get your 10K pace.
But to answer the question in the way it's been posed, the tool doesn't just say 0 to 10 is at this pace and then 10 to 20 is at the next pace. It does actually smooth it out, so it's a progressive thing.
Yeah, so it sort of drops linearly in essentially in distance, if you like. So as Terry said, if you start at say 18 minutes per K and then you slow to 20 minutes per K at 10 Ks, the model is going to assume that you're going to continue that rate of decay. So by the time you get to 20 Ks, you've now slowed to 22 minutes per K.
The other thing to recognise is that if you're swimming in either a duo or in a team and you have a faster swimmer and slower swimmers, if each swimmer is going to do the same amount of time, the faster swimmer will cover more distance and the slower swimmers will cover less distance. And so there's also some balancing out happening there.
Perfect. Alrighty, so just going through the Q&A, there's quite a couple that came through earlier. We have been replying to them. So if you still have questions, just reply back and I'll come back to them a little bit later. But if you do have a comment against your question, I won't answer them right now. So one from Bill, who's asked a few questions. Thanks so much, Bill. So one of his questions is, if swimming into large seas, then the swim speed can be much less than pool swim speed, even accounting for current. I understand you've adjusted for that. Is that correct?
No, it's not. So at the moment, the app doesn't account for waves, and waves can affect you in two ways. They can cause you to drift, like if you had a cork drifting on the surface of the ocean. That drift is usually quite small, though. It's probably only on the order of a few centimeters per second in terms of a speed. The second way the waves can affect you is because they can affect your swimming technique and they can potentially fatigue you as well. We don't account for those effects at the moment. And I think Terry made a really important point, is if you are likely to err off your route accidentally, we'd probably suggest you err to the south of your route, just because those effects that we haven't accounted for are likely to slow you down and are likely to drift you north, right? So we think, ideally in future years we'll have waves incorporated into the app, but at the moment we only have them in a beta version, which is not available for sort of wide release. So
we are working on it.
Yeah, great question, Bill. But yeah, we haven't got that incorporated yet.
Watch this space for future developments, everybody.
Yeah.
On that, the app was developed, the tool was developed quite a few years ago, as everyone knows, but in partnership with Aurora Offshore and Engineering and UWA, it is developed year on year. So that's why if you look at it out of season, it does it might either be down or it might not be the most relevant. So we do try and update it. And we are looking to hopefully one day incorporate it into the app as well. So you won't have to export and upload. Hopefully it will be all in the one tool as well. Cool. So we've got another question here from Bill. So your examples of routes at slow speed don't seem to have taken the 1.5 kilometre restriction into account. This year, anything slower than about 16 minutes kilometre follow similar routes. Any comment on that one?
Yeah, I mean, at the moment, anything slower than sort of 16, 17 is going to hit that 1.5K limit. So the routes look quite similar. Yeah. I mean, in an ideal world, Bill, we would not have the limit. And what you would see is that as the speed slows, you would get bigger and bigger offsets and bigger savings from taking an optimum route as well. But at the moment, I was just playing around as I saw your question. Yeah, when we run anything sort of slower than about 16.5, we sort of hit that 1.5K limit.
Perfect. Thanks, Scott. Another question we've had come from Bryce Ingram. I'm going to hand over to Josh McCleary, who's the executive officer, who looks after more of the on-water side of stuff. So this question here is, what sea/wind conditions would cause an event cancellation?
So that question's a little bit of a tricky one to answer, because it's different wind strengths from a different direction wouldn't necessarily cause a cancellation. Typically, we're looking at a 20-knot wind from the southwest pushing a larger swell, 2.5 meters plus. We'd be looking pretty closely at a cancellation of the event.
Perfect. Thank you. Bryce, if you have any further comments or questions on that one, just flick it through and we'll try and answer it at the end.
Sorry, is that a chance just to jump in and refresh our memories? But as I understand it, there's a text message goes out to all the registered mobile phones on
Yes.
the event day at 4
So
a.m.
at 4 a.m. we do have a go/no-go text that will go out to all swimmers, all participants and skippers, everyone that we have a phone number for. So that's when we will be making the call whether we are looking to start with the waves.
Are you able to make any comment at this stage? At this stage, is the event looking like we should all be doing our carb loading and preparing as though we are going to step foot onto the sand and dive off into the Indian Ocean?
It is definitely far too early to make that call. If we were certain that weather conditions were going to be difficult, meet those thresholds this weekend, we would be looking at cancellation, but we will be not unlikely to make that call before Saturday morning event because we'd really love to go ahead, and I'm sure most of our swimmers would like to. But if it is considered dangerous, then we will cancel the event.
But at this stage, we need to be preparing as though we are swimming.
Yes.
Yeah. Get carb loading, Terry. Get ready.
Absolutely. Pasta tonight, pasta tomorrow night.
Who am I to get in the way of your carb loading?
Too right.
Perfect. Alrighty, I'll move on to the next questions. Thank you for stepping in, Josh.
All right.
Perfect. Alrighty, so only a couple more questions to go and then we'll wrap it up. So this one is from Peter Roberts. Thanks so much. So first one is awesome update. So I believe that's a shout out to you guys as the developers. Thanks so much. One of the quick questions though is there any benefit resetting the route tool on the morning during the swim?
No.
No.
As Avitsa pointed out, the last update to the forecast happens at 8:30 to 9 a.m. on the Friday morning. So beyond about 9 a.m. Friday morning, the forecast that sits behind the model hasn't changed. So unless you get some sort of sudden burst of energy and want to go twice as fast, then by all means rerun, but it's based on the same weather forecast.
Sweet. Perfect. Thanks, Terry. And there is a question in here from Kim Rodriguez just about uploading the GPX file rather than the other one. I might leave that one to be handled offline if that's okay, Scott. Is that all right?
Yeah. Is it?
Yeah.
Looks tricky, or yeah.
I think it's just about the process of trying to upload it into a GPS system.
So I think that varies depending on all the different GPS systems. So often for like a handheld, there's a USB cable that you can plug in the back, and then you can transfer it across from a computer and upload your GPX file that way. If it's a fancy modern GPS system with Wi-Fi and all of that, then read the instructions was certainly the first good starting point.
Yeah.
Perfect.
There's also JC, just quickly, there's an email address at the very bottom of the page with the route optimization tool, and if anyone does have like a technical question, you can email it to that email address if they want to.
Okay, and it comes to your team.
Yep. Come to us. Yep.
Right, that's good to know. So it's on the bottom of the Route Opti tool, like the web link.
Yeah, it's
Perfect.
UWA email address. Yeah.
Love that. There's one more question relevant to you guys, and then I'll just answer the last one quickly. So thanks, Craig Gow, for this question. So do you have an estimate of the decay in speed that is purely the result of swell height? At present, it may be 1 meter off the beach, but over 2 with season swell when in the channel.
As Scott said, the influence of swell on swimming speed is actually relatively small. We're talking a few centimeters. So, the current is forecast to be about 0.6 meters per second. The influence of the swell is like 0.03 meters per second. So it's actually the swell, the really big waves, actually have relatively low influence on swim speed. They might make everyone on the boat chucky over the side, but the swimmer just tends to ride up and over them.
Perfect. Alrighty. That seems like all of the questions on the Route Opti tool. So I'll just quickly answer this one in regards to the weather again. So thanks for your question, Marianne. So in regards to the race weather updates, tomorrow when we send out our final e-newsletter to all participants, so if you've registered for the event, regardless of the category, so if there's a swimmer or a skipper, you'll receive this e-newsletter, and it does have a race director weather update in there. It is more of just a generic overview of where we're at with the currents, etc. And then come event morning, as Josh mentioned earlier, at about 4 a.m., 4:30 a.m., the no or no-go text messages sent out. So that's the final confirmation of if the event is proceeding or not proceeding at that point in time. Perfect. And all the other comments on there are just saying thanks so much for your time and presentation. And that is also shared from us here at the RCSA. So thanks so much. As mentioned, the slides and the PowerPoint video will be uploaded hopefully tomorrow morning to both our event website and our YouTube channel. So keep an eye out. Thanks for attending. We look forward to seeing everybody across at Wadjumap come Saturday.
And good luck to all the swimmers.
Yeah, definitely. And thanks, JC and Josh, for your input and help as well.